There we go. Looks like we're live. Hey, welcome everybody. Welcome once again to Astronomy Daily Live. So hope everybody's doing well out there in the universe and the world. Yeah, so this is just a casual daily get-together of friends coming together, sitting around on our virtual porch, grabbing our consumables of choice. I've got the coffee here, a little bit of coffee, so cheers. Still hot. And of course I have the hydrogen hydroxide once again. So a nice full mug of that. So yeah, hope everybody's doing well. So we gather together each and every day. Hey there, Carolina Sky Astronomy. Good well, I can't say good shots at Jupiter and Saturn, but at least you got something, man. It's been you were saying, that it's been cloudy there and everything. So yeah. Sometimes we just sort of need our fix, and the quality doesn't have to be great. We just need our fix, right? So yeah. Great to get those shots. Averaging and stacking, of course, does wonders. So yeah. Great stuff. I'm glad it was satisfying for you to get out. So Andy, hey, nice to see you. Tom, nice to see you in the chat as well. And let's see. Well, I might as well say howdy to Bobby. We were talking about the Falcon Heavy launch. So hey there, Bobby. Let's keep talking about that a little bit, huh?
Yeah, I agree with that, Cosmic. It's fun of a word. If you haven't seen it yet, a beautiful launch, a beautiful unload, and it's flying like a bird. And
they actually recovered the
yes.
fairings too. The two things that cover up the satellite at the top.
The rockets in the center core.
Yeah. So
that was great. If you haven't seen it yet, you should see it.
Absolutely. Yeah. Great launch. This is kind of an interesting. I don't know what's going on with this satellite, but I guess it has an apogee, which is its furthest point of 90,000 kilometers. So it's going way out there, and it's coming all the way in. So I don't know. I don't know if they try to circularize that orbit eventually. For this satellite, to actually be launched, you didn't need to use the Heavy at all. But there was some kind of explanation. I'm not exactly sure what, but it was decided, and man, that thing was flung out there, just wham, like that, right? So yeah, great launch, right on time. The first two boosters, they separated, and they flew back and landed. Not quite as synchronized this time, which I don't expect any kind of synchronization. They are individuals who are going through their own things, but yeah, that the landings of those was absolutely epic. The core stage, the center stage, they actually landed out in the middle of the ocean, and that was a success too. In fact, that what I saw is that it landed like right in the center, right in the middle of that thing, and
yeah.
Look, that is a testimony. All of this is a testimony to, you know, the team of engineers, the hardware folks and the software folks who make that all go. It's absolutely astonishing. Still, you know, I keep thinking about this every single launch. It's like, when is this gonna get like boring and normal? It's like, oh yeah, you know, they launched another one and they landed them all. Okay, you know, who cares,
And
right? When is that
doesn't
going to
matter how
happen?
old you, how doesn't matter how old you are, you're still gonna love those launches.
Well, you know, if this becomes more and more routine, right, there is going to be a point where it's going to be, you know, as exciting as watching like an airplane taking off. Now, to me, watching an airplane taking off is pretty cool, right? It's pretty cool, but I'm not going to watch it on the TV. I'm not going to go, you know, go out of my way to go watch one. But you know, that's what's happening, you know, with these rocket launches, and I suspect that is probably how it's going to be for a while, because I mean it's still very, very novel and very, very unique, and it's something that, you know, I think we have wanted to do for a long time, and it's kind of sci-fi. It's not quite as sci-fi as something like the space shuttle, but it's still sci-fi. But it's sort of reasonable sci-fi, so yeah, it's just absolutely, you know, I mean, every single time, you know, I watch these things, I can't help but just be like, yes, all right. So is that going to end at some point? Yeah, yeah. Is it going to end some point soon? Probably not. It's just a little too cool. It's just a little too fantastic. So
I don't know. It's better than nothing on TV, that's for sure.
Well, you know, the neat thing is that those three rockets that they use today, you know, the two side ones and the one center one, they're actually going to reuse on the next Falcon Heavy launch. So they're going to reuse almost the whole thing again. You know, they still haven't figured out how to get the second stage back. That's a harder thing because it's going so much faster that you know, it would have to go through a re-entry, and you know, that's it's entirely possible. It's entirely possible, you know, to do that. But
all right, so second stages will be pretty much be staying afloat, right?
well, the second stage eventually just burns up in the atmosphere, right? I mean, it goes up and it goes around a little bit, but eventually that comes back down, and you know, it just burns up in the atmosphere. But there's you know, I mean, in a very, very, very simplistic way, the only thing that you really have to do is put some thermal protection on that thing, so it can safely re-enter, and then of course it would have to land. So that's a harder problem to solve. You know, basically because what I said about the velocities. I was actually looking. You know, they SpaceX they show, you know, the velocity and the altitude of the second stage while it's going up, and the I saw it go past 25,000 kilometers per hour. So that's like super fast. That's really fast.
For sure. And I
Fast.
think if I recall correctly, I think it did like over 35,000 kilometers. It could be more, could be less.
Oh, did it? Wow.
It's not going to be less.
Yeah, I
know it's not going to be less, but it's definitely going to be more than that. You're just going to have to watch the thing and really find out for yourself.
Yeah. But yeah, so Falcon Heavy is basically 3 Falcon 9s. It's 27 engines firing at the same time. It's just insanity, right? Now that is nothing compared to whatever they're calling the Starliner or the BFR, or I'm not exactly sure. I don't remember how many engines that's going to have. Maybe somebody in the chat knows, but it's many.
I'm not sure if anybody in the chat may know, but Jim could be right about this. When we stop sending up rockets and start sending out starships, then he will be impressed.
Okay. All right. Well, yeah. I totally agree, and that is coming. Hey there, Chuck. Nice to see you in the chat. Too. Cheers.
There's Chuck. Hey, Chuck.
Yeah. So absolutely epic. So on some sadder news, the Space IL spacecraft that was planned to land on the moon today. Unfortunately,
that's what I heard.
Yeah, unfortunately, something happened to the main engine, or I haven't heard any kind of details or anything, but it did actually land on the moon, but I think it landed a little rough. So yeah, it crashed into the moon. So that's a bummer.
So much for having a telescope. So much for having a telescope on the moon.
Well, now you might think that, but others have landed on the moon. Okay, so we will learn from this, and they're going to find out, hopefully, exactly what happened, and they or somebody else will make the corrections and try again. And yeah, this is not the first ever landing on the moon. So the fact that this was a fail. There have been a lot of failed landings on the moon and on Mars, and even on the Earth, right? So
this is like the first time there was a failure landing on the moon.
Oh, absolutely not. No, back when the United States and the Soviets were launching probes to the moon, they crashed. I don't know if I can say a lot of them, but yeah, they crashed a few of them into the moon, before they got it right. So that's.
I know for a fact that when they're trying to send stuff to Mars, because of the technology they didn't have before the InSight and the Barcosats, you did expect some failures then.
Well, they the Russians and or the Soviets have yet to land anything successfully on Mars. I think that's a true statement. So
what is Space Force?
Space Force? Well,
yeah.
that's a proposed extension of the Air Force that is going to deal with space things. The Air Force is the sector of the military that is currently sort of in charge of space things, and
You want to
um,
know something? Here comes that 1940s style UFO like starship.
yeah. So yeah, just like the Army separated into the Army and the Air Force. The Air Force is probably likely to eventually separate into the Air Force and the Space Force. That's all. So yeah, that's just a logical extension. Um, yeah, that just makes sense. If you're going to have a military, you're going to have to do that. So it's debatable, if you need a military or not. But
Yeah. I don't think we need a military to militarize space yet.
Bobby, it's already
Now,
done. It's already done. That's a done deal. That was a done deal back in the '60s. So that's a done deal.
oh yeah,
Space
sci-fi.
Space is extremely militarized. Believe me, yeah, yeah. Uh, the military has their hands all over space.
And did you not know that Tom, speaking of failed moon missions in 1970, when Apollo 13 launched and things went south, but they all survived. That was a good thing.
Yeah. Wow. Okay. So that launch happened
You know,
today in
we need
1970.
and to what Jim says is also true. We probably might need an SGC.
Yep. I totally agree. Um, Jim, as soon as you get yours working, let me know, because I'll definitely want to check that out for sure. Just give me a call. All right. Well, great. So yeah, we had a success,
Yeah.
and a failure today. Yeah, yeah. It's always exciting times, and in
Now I wonder if we can actually find a real Stargate around Egypt.
Well, I guess we just got to keep looking. So yeah, it's the idea of a Stargate is I suppose within the realm of possibilities. I don't know if there is such a thing. Hopefully we'll be able to use it in some kind of a really really nice productive way. So whatever that might mean. So all right, well, cool. I'm gonna take another big gulp of this coffee here.
Yeah. Yeah. I'm not sure if they're bringing back the Stargate franchise since that universe fiasco.
Okay, yeah. Well,
That would have been great if they brought it back.
Well, I'm always in favor of something new too. That had a good run. It's a great idea. It's a great concept. They really have wrung that out. For almost all it's worth, I think. I'm in favor of something new.
The last time we talked about Stargate and its franchise and stuff, so I guess the original dude Peter before I think something. Is it true that something happened to Peter with Bert and it could be in a producing universe or something?
I don't know enough about Stargate to really be able to say much about that
Either I probably don't
at
know either.
all. Yeah, yeah, not quite sure. So who knows? Who knows? All right. Well, what I thought that I would do today, and actually I started before the live stream started, and again I sort of had to say stop, stop, stop. Let's do this during the live stream. There's a relatively large sunspot that is currently on the sun. And what I thought that we could do is go over to IRIS, which is a spacecraft that is actually an 8-inch telescope. It's this size of a telescope,
And
looking
as of
looking
just
at the sun.
3 minutes ago, your solar flux at 78, your A's at 10, K at 1, sunspot number at 13.
13. Nice. What's the K index? What's the K index again?
Let me see if I can get that 1.
Okay, so not anything to get excited about, I guess. So, okay, but yeah. So Iris is a telescope.
New sunspot. There's a new sunspot, or the other one went bigger. Or the other one probably went big. That's big.
Yeah, it is really, really big. Um, Iris is both, and it takes images and it takes spectra simultaneously. So there's a lot of useful, um, uh, uh, extremely useful information in both a picture and a spectrum. And so what I thought is we could go over to that site and take a look at their data. They send out their data extremely regularly. You can usually, well, we'll take a look here in a second, but usually it's just, sort of a day old or so. And of course, they have an archive. You can go all the way back. At this point, Iris, wow, Iris has been in orbit around the Earth. It's in what's called a sun-synchronous polar orbit. So it's actually going around the Earth, but it's such that it's always able to see the sun, or almost always. Much of the time. I think there's a couple of times a year where the Earth gets in the way. I'm not exactly sure what the details there are, but fact of the matter is that it can observe the sun all the time, constantly, and that makes it a very, very useful instrument when you want to watch very, very, very dynamic things like the sun, right?
And speaking of like sun or any other stuff like amateur radio and stuff like that, I just want to let you know, between now through the 14th at 8 on 1800 hours UTC on the 14th of this month, ISSSCB event.
Nice. Yeah, cool.
I had 2 pass opportunities, but they were not so great.
Oh, all right. Are you
now? There was a 21, which wasn't the greatest. Right. I managed to catch a 25 one, but the modulation wasn't the greatest.
Okay. Yeah, that's a little bit low, right? 25 degrees above the horizon. It's a little bit low.
Yeah,
Probably want to get up a little bit more.
yeah.
Are you going to have other opportunities, or is that it?
Yes.
Good.
Yes. Tomorrow, like around about 11:30 ish, I'm gonna like have like a 43 or 44-degree opportunity first thing
That
in the morning.
that might be better. Yeah,
Yeah.
that's good. Yeah, that's
Yeah.
getting up there a little bit higher. So yeah, why don't we go over to the Iris website and we'll look at the sun um, um, for a little while. Now, the Iris spacecraft takes very high resolution images of the sun. So you're not going to see the entire solar disk. You're just going to see little tiny portions of the sun, but they're extremely high resolution. I think the images. Trying to remember if the images are in the visible part of the spectrum or if they're in the ultraviolet. I don't remember exactly. Yeah, we might, we, um, we might be able to find that out. But let me make sure that we're over here, and I'll post a link to the main Iris website here, so you all can follow along or check it out later. I actually, haven't looked at the main site for quite a while, and I want to dive right into the data, so I'm not going to linger on the site too much wandering around, but I'm going to go ahead and share my screen here. Oh, let me do that. Push the right buttons. Da-da-da-da. Go to infinity, down the wormhole. I love it. Okay, so here's the main site, and the one thing I noticed about the main site is that their latest current news is as of the 11th of July 2018. So nothing new is going on with Iris in terms of operations or anything else. It's just
But it's
gathering.
still updated with the movies and the pics and stuff, right?
Oh, absolutely, absolutely, and we're going to get into that right now. So if you go into data, and then we can go to recent observations. Now there's a lot on this site, but we're just going to go to recent observations, and you can see that the latest data is from yesterday, I guess you'd call it, um, um, the 11th of April at 10:57 UTC. So that, you know, like I said, this site is very much kept up to date. Now, the only thing is that the actual data, the actual raw, scientifically valid data isn't available yet. But they, provide a lot of information in terms of the observations made, what kind of data was collected, where it was on the sun, on and on and on and on and on. But let's just look at this latest one, because it looks like that, to me, looks like that big, huge sunspot. And actually, let me zoom in a little bit so I can show you. So these are the wavelengths that were observed, and yeah, these are all towards the ultraviolet. All right, so these are in angstroms. So yeah, this is all part of the ultraviolet. But I think what they do almost right away is they provide some um, 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 animations here. So let's, I don't think they have any animations of the spectra, but let's just load up one of these. And of course, you can see how the sunspot looks at different wavelengths. And that's sort of a combination of, you're looking at different kinds of materials, and you're looking at different layers in the sun as well. But let's take a look at this one, because that might be pretty interesting. So I'm just going to load up this JavaScript thing, and it's going to take a while to load. There's 169 pictures here. Now what you'll see right down the middle here is this black line. What that is, that's an actual slit in the mirror. In this telescope mirror, there's a slit, and light goes through that thin little slit and feeds the spectrograph. But once this is loaded, it'll start to run a little bit faster, and we can watch and see how incredibly dynamic this spot is. So it's still loading. Almost done. Almost done. You can see the timestamp here. So yeah, this data is about, what, 12 or 14 hours old. Ooh, look at this thing right in the middle there. There's a little tendril. Okay, so here it is running, and you can see how incredibly dynamic even the sunspots are. So they're, this goes into a loop. You can see all the granulation here, all these little cells. I think those are commonly called convection cells. Whether they are or not, they are definitely there, and they are just bubbling away. But you can see that there's just a lot of action here. I wonder if we can zoom in on that. Ooh, we can. Let's see. Let's see if we can get in on that spot and really see some interesting action. So you can see that there's, it looks to me like, there's material actually going out and going in at the same time. So that's kind of neat. And this tendril, you can sort of see, evolves over time. I don't think that this is a very long observation. I think it goes, we can actually look and see here. So this goes from 1057 to 1430 UTC. So, this is about a 4-hour time span. Look at these up here, how they, it looks like fire, just sort of bubbling around and everything. Isn't that amazing? And yeah, this is, I don't know, the exact dimensions, but I would definitely say, this is multiple times the size of the Earth. So, this is a very, very, very large structure. Look how just absolutely black it is in here. Just absolutely black. They commonly say, that this is a cooler region. So yeah, I don't know if it is or not, but and then see all the light from here is actually going through the spectrometer, and so they can actually look at the spectra of these different regions here, and they've sort of probably pretty carefully placed this slit so it sees the surface of the sun, but it also goes through the penumbra, which is this part, and then a little bit of the umbra, which is this dark part. So they're actually getting a spectrum of all of this stuff. So pretty cool, very, very active place. Definitely, it'd be interesting to maybe be there if there was a relatively safe way to do that. But ooh, yeah, I think we need to observe this thing from a distance. Now the cool thing is, right, is that this is an image with an 8-inch telescope. This is an 8-inch scope. Absolutely fantastic, though. That's what happens when you don't have an atmosphere to contend with, right? This thing is out in space, so it can just see things as they are. But yeah, just an incredibly dynamic place. Now, let's look at this at a different wavelength, at a shorter wavelength. Okay, we'll look at exactly the same place. I'm going to zoom out here a little bit just for a sec, so we can let this thing load. I'm going to take a sip of my cool down coffee here.
Now, have you ever tried instant coffee?
I have. I'm yeah, I'm not a huge fan, but yeah, I have no problem with it. Times of desperation, we can definitely do instant, but I try to not be that kind of desperate.
Yeah. The way how my microwave functions, it takes about 3 minutes to really warm up the water and then put the coffee in it.
Oh, okay. All right. Wow. So
yeah. But that's my microwave. It's an olden style, so I'm not sure how good your microwave is. Your microwave could be better.
Yeah, I think for a mug, I put it in for like a minute, and it's usually nice and hot. So yeah, so look at all this activity here. There's material moving around. We can zoom in a little bit here too to really get a good shot. Here's that tendril, right here. Here's that dark region, and now you can sort of see that whatever is happening here, it's sort of just sort of flashing, and that's been observed and noted that the umbras of these things, they just sort of get bright and dark like that. But you can sort of see that material seems to be going almost both ways, right? There is some moving out stuff and there's some moving in stuff. So pretty amazing. And up here, yeah, you're sort of seeing a little bit of activity there. I mean, on the scale of the Earth, I mean, that kind of thing right there would just completely destroy the Earth, right? But it's a minor little thing on the sun. It's hardly even noticeable. So yeah, you know,
Almost looks like you got some smudge on your screen as well.
yeah,
The
yeah,
black spots.
right, right. And again, you can see the slit, right, down the middle
Yeah,
here.
I wasn't worried about the slit.
Yeah. Anyway, so that is pretty amazing. And that is what is happening right now. There's just, I mean, it's constantly changing. I'm sort of looking here, and you see how these things just get brighter and brighter and brighter, and they're slowly moving. They look like they're slowly moving to the left. I'm not quite sure if it is or not, but because the sun is actually rotating. I think the spacecraft is able to track the spot, as it sort of moves across to the face of the sun. So yeah, this might be, some actual movement here, but it's just, I mean, it's just an incredibly dynamic place. And these are the sunspots. I mean, these are sort of the busy places on the sun. But even the most non-active regions on the sun are it's just busy. Um, so this is kind of neat because they let me zoom back out here a little bit. They oftentimes will well, it's not giving us a great context here. Anyway, here are some of the spectra that are taken. So along this axis, so along the left-right axis is wavelength, and along the y-axis is location. So here's the slit. So the spectrum of this region here would be down here. And the spectrum of this little bright area right there is right along there. So this is the position on the sun, and then this is wavelength. And they are looking at some pretty specific spectral lines. They're looking at the magnesium K lines, as they're called. And this is a very complex thing, as you can see. They are looking at silicon, and you see how it's not a straight line. Some of these features are sort of this way, and some of them are that way. That is Doppler shift. That is because these materials here, let's see, I think I'm right in saying that towards the right would be longer wavelength, and towards the left would be shorter. So if things are sort of this away, that means that that material, which is right about up here, is moving away from us, right? It's slightly redshifted. And then there are some other things down here, right, which is maybe this stuff here that is slightly blue shifted. It's coming towards us. So we can actually see that. It's absolutely fantastic. Here is the oxygen line, which doesn't look like there's a lot of oxygen in this area. And here are some carbon lines here. Again, it's like a doublet of sorts. So yeah, lots and lots of information this spacecraft provides us. Let's so what we can do, let's go forward in time, or actually backward in time a little bit, and see what else they have. I'm sure that they have a lot of interest in this spot. See, so here's another image of the spot. Here's part of the limb of the sun, the edge of the sun here. It's always interesting to see. Here's some more of the spot. You can sort of see it looks like it's active region 12738. So anywhere that you see that, they are looking at the sunspot. Here's some more down here. So this was all taken in the past couple of days. Go to the next page here.
Focusing on that sunspot more than ever.
Yeah, well, sunspots are pretty interesting things, and so it's nice to look at that. But they monitor things too. So they look at sort of not incredibly exciting areas, just to sort of see what is going on there too. So here's more of the sunspot. Here's some more. Here's some more going back. I'm kind of seeing when we start to get some actual data over here. It usually takes them a couple days, a few days to, yeah, so here we go. So here's some actual data, and this is the scientifically valid data that you can grab and work on if you want. Let's oh, okay, it's we don't have anything here. Let's keep going here, because I think what I want to do is I want to load up a little movie showing the spectra as well, because I'm probably not sort of describing it or explaining it incredibly well, and it's just a lot easier just to show you than it is to try to explain it. So let's try to find a something moderately interesting here. Here's they like to look at the north and south poles, because there's always all kinds of interesting things going on up there. Yes, these North Pole, South Pole. Oh, here they're looking right on the edge there. Okay, keep going backwards in time here. So this is, I think, before that large sunspot appeared. Yeah, we're back on April 4th now. So let's see if we can. Well, yeah, no, there's some. Let's see if they've got their movies up here. Doesn't look like it. Yeah, they used to show movies of the spectra too, but I'm not seeing that anywhere here. So I'll keep going here a little bit. See what we can see. Maybe what we should do is I don't know if I think this is just, yeah, okay, that I'm not going to do. Let's see, how do I cancel it?
There you go.
Yeah, there we go. Let's just, let's go on another one here and see if there's any. Yeah, shoot.
Yeah, but they used to do videos, but I think they stopped it the last time we went.
Yeah, well, they've got the little JavaScript things for these, but I don't know what What's this
I don't know.
thing?
Yeah, they got that JavaScript. They got the
Oh,
some
here's
like
yeah.
there's
Here's
like some.
here's an MP4. We can deal with MP4s. So let's go
Yeah,
back.
yeah.
Let's go,
And you look at the QuickBooks. They got some MP4s as well.
yeah.
I don't know what SSW is.
Let's go back to this and see. I'd really like to show you how these spectra change. So let's go here and go down here. Oh, there we go. That might do it. There we go. Okay, so we'll let this load, and then you'll sort of see how the spectra change as well, and you know, the the image, of course, changes, but what the spectrograph is looking at is changing as well. So, like I said, this direction, you know, the up and down direction, is location on the sun. So, you know, this corresponds to this, and over here and over here. You know, the middle is here and here and here and here. And then this way, left and right, is wavelength. So we'll let this thing load here, and then it'll become pretty apparent what is going on, and you can actually watch the spectra change as, you know, the spectrograph is actually looking at different things, because of course the sun is always changing. So it wants to load. Okay, it actually ran. The spectra ran out right there. Okay. Well, we'll continue to let this load since it's almost done, and then we'll watch it loop. It'll probably go into a loop again. It's loading pretty fast. Here we go. All right, here we go. So let's zoom in on the carbon first, so we can really see what's going on there.
But no, so something must have happened during the during the during the observation. Something must have happened with the telescope or something.
Yeah, you know, they turned it off, or you know, they don't have any of the data yet, or something. But
I would
yeah,
say
this
they
thing
just turned
loops.
it off.
So but
I still say they
yeah,
turned it off.
who knows? Who knows? Okay, I'll let you say that. So yeah, you know, it's just constantly changing. Maybe we should find one that has more of a constant thing.
Well, you're starting to lag too.
And you know, there's noise. You got to deal with the noise, but there's. Oh yeah, I'm not surprised. The old potato here is really having to work hard. There is the silicon spectrum. Oh, there it goes away. It'll loop back around. But you can see how, you know, it's just absolutely incredibly dynamic. Here are the magnesium lines. Let's see how that goes. And you know, there's both emission and absorption. So let me pause this. Oh, I don't know if I can. I guess I can't. See all these dark lines in there? Those are.
You might have to zoom out for that.
Yeah. See all the dark lines here? These are absorption lines. So that's all real stuff too. And of course, the magnesium lines are emission lines. Pretty amazing, extremely dynamic. Let's let's pull in a different one, because that lack of spectra there is kind of annoying. Whoop.
Oh, what the heck did you just do?
Oh, I don't know. I do all kinds of crazy things. Oh, let's look at this one. I don't know. We haven't looked at this one yet. So, okay, well, it doesn't look like there's any spectra there yet. So let's come down here a little bit. Let's take a look at these. The spacecraft can also scan. So what you're going to see here is that scanning motion. Let me do that. And we'll come down here and hopefully, okay, so it doesn't look like there's a lot of data here. Yeah, 26 images, but we'll let them load and then we can take a look at them again. So there we go. It's just in a fast loop here. So you can sort of see this bright area right down here. That's what we're seeing here and here and here and here. So see how that works? That's why the up and down is the position, and then left and right is the wavelength. You can sort of see that bright region makes some really broad lines, which is an indication of temperature. Right, a broad line means I think that it's hotter. And we're sort of seeing that all these lines, they brighten up a little bit and get really wide. So that's pretty cool. Yeah, I think I found what we're looking for here. So let's see if we can 320 images. Well, let's take a look at this one too then. Should probably I'd like to show you how this thing scans as well. So I'll let this one load, and you can see that they can change the position of the spectrogram too. So not only can they look in sort of the up-down way, but they can also scan left to right. And so it's absolutely amazing, the just huge amount of data that they can get from this instrument. And as you can see, they scan over and over and over again. I'm gonna slow this down a little bit so we can see a little bit better. So see how they're moving, and they're actually, I believe that they move the whole spacecraft in order to scan this. I think. So of course there's that sunspot again, way down here. But they're looking at a portion of the sunspot, and then they're sort of scanning out of it as well. So that's pretty nice. So let's go to this one again, whatever that means. And let's load up. Oh, so this is just a few data points here, but that's okay. We'll load them in and take a look. So you see all these black lines here? That's all real stuff. It's just absorption as opposed to emission. So these are atoms that are actually absorbing light at those wavelengths. Here's the magnesium lines that are emitting light, and then you've got all these other lines which you know aren't magnesium. You know, there's something else that are actually absorbing light, which implies that there is light coming from the interior. So by looking at these absorption features, you can actually learn things about the inside of the sun that way too. So it's pretty amazing how dynamic this object is. I'd like to get a long sequence of spectra. Let's see if we can find some here. Let's see. Oh, nope, there's only a few data points there. Let's go way back in time. Let's go. I'm just going to randomly go back in time, maybe a month or so. Yeah, let's go back a month in time and see if there's anything interesting here. Oh, we can look at maybe this one. We got any more interesting data here? Oh, there's a few more data points there. These spectra, when you're looking at the edge of the sun, are pretty interesting too. So let's look at that. It might be kind of neat. Wow, 229 megabytes. Let's do it.
And that's the MPEG.
Oh yeah.
That's the MP4.
Okay, that's probably going to take much longer than what we want to wait for then. Yeah.
Yeah.
Ah, bummer. No. No. Oh. Coline movies? Is that? Yeah, I should have gone here first. So we can look at it. Oh, I don't see it there.
Wow. We're looking deeper than ever before.
I agree. SSW page, that's where we were, right? Yeah. Doesn't look like they have any JavaScript on that one.
Yeah.
Let's try another one then. I'm just randomly grabbing this. As you can see, there's tons and tons and tons and tons and tons of data here. Let's see if this is going to give us any satisfaction. Nope, just an MP4 again. It's just a few data points too. I'm looking for a spectral sequence that's a little bit longer. For some reason, I'm not having any luck with that. Plume region at the North Pole. Let's look at that. Oh yeah, there's just a few data points here. So,
So they haven't not been doing a much for a better job utilizing this.
Well, you know, the real data is here. Okay, so you know, all of these are just you know, sort of like quick look things. So I'm not surprised, that there isn't a lot of stuff here. All the good stuff is in here. Yeah. But yeah, let's. Why don't we take a look at a couple of these just for fun? So this, I think, is the North Pole. And again, it sort of looks like they're scanning a little bit. It's all right. You can see, they've got some bad pixels in here. These black things almost look like spaceships. So we'll let this thing load. Yeah, there's only 210 images, so this should load pretty quick. These little things are called spicules, and they just well, as you'll see, they just sort of shoot out and then fall back down, and then they'll shoot out again and fall back down. It's a busy place. The sun is a busy place. Well, about halfway there. Again, you can sort of see that black line where the slit is, the spectrograph. It's great. They've got an 8-inch mirror that it's actually two halves, and right in between them is this little gap. So absolutely brilliant design. So there we go. And this is over the course of, it's over the course of a couple hours of time. So yeah, this is very, very much sped up. But yeah, what a busy place the sun is. Absolutely amazing. It's you can sort of, that's a pretty busy area right there, shooting out all those spicules, as they call them. I think a lot of this is noise. I'm not sure if that's actually stuff going on the sun itself, or if it's just noise in the detector. You see how it's spotty up here? I think a lot of that is noise. But great resolution anyway. Okay, let's keep looking here a little bit more. Is there anything else that pops out? Plume region. So this is March 10th. March 10th. Just sort of scanning around. Not seeing anything that's necessarily catching my eye. It's not really going to be any prominences or anything, or not very many. Prominences are usually associated with sunspots. And that's actually an interesting thought. We could theoretically look at some prominences as that sunspot was sort of coming around. I don't remember when exactly that was, but we can we'll take a look here, see if we can find out a little bit. Flare watch. Oh, that sounds exciting. Oh, there we go. Oh, there's lots of data here. Let's see if we can see anything here. It's an MP4 again. That's not incredibly big. Let's see what this shows. We'll go from there.
You know what would be good when it comes to input for videos? If you right click on it and click on copy link, and you run your turbo and do wget and then paste the link into the turbo, and and you press enter, it should download the video from there.
Oh, okay. Yeah. I could do that. We'll let this thing
wget should be available with all Linux distros for sure.
Yep.
You can always get it if it doesn't.
I use it all the time.
Yeah, wget's a good piece of software.
Yep. I agree. So there's 800 images to load here. So this.
Yeah, out of my curiosity, you probably never fiddle with MPlayer.
MPlayer?
Yeah.
I don't know if I ever have or not. That name rings a bell, but I don't know if I ever have or not.
Yeah, MPlayer's console style as well, but it does do wonders.
Nice.
Now it does still play video. Don't get me wrong. Video and audio.
Right. So do you notice this?
Wow.
You know what causes that?
Well, I forgot.
That's the when the spacecraft moves through the South Atlantic anomaly.
Yeah.
It makes all kinds of electronic noise, and that's exactly what's happening there. Is that you're seeing that. So once in a while, the spacecraft has to go through that, and it's tough enough to do that, of course. So I'm kind of anxious to see what this is going to look like. We're about more than halfway.
I didn't know there was a such thing as a South Atlantic anomaly thing.
South Atlantic anomaly. Check it out. Check it out. What it actually is a it's sort of a low spot in the lower Van Allen belts. So it's a place where the magnetic field of the Earth is a little distorted, and so all kinds of electrical things can happen, and there it goes again. Isn't that cool?
It is yet finished loading.
What's that?
It is yet to finish loading, huh?
Yeah, it's almost done. It's up to 680 out of 800, so we're almost there. Almost there. With astronomy and science, oftentimes you have to be patient. You have to let the data flow. So that's what we're doing. All right.
Here we go.
Almost. Couple more. It's like watching the grass grow. Here we go.
I just had to cut grass today.
There we go. So, as I suspected, not incredibly active, but you'll see when the spacecraft moves through the South Atlantic anomaly. There it goes. Well, isn't that cool? And it's going to do it again here. I think I noticed it a second time. And there it goes. So that was one orbit. Spacecraft went around the Earth once in that amount of time. So yeah, doesn't look like there's a heck of a lot of activity here, but yeah, I'm sure they gathered lots of data on that. So very cool.
That's about it.
Very, very, very cool. Wonder, I don't know what these things are. Co-aligned movies. Oh, they're all MP4s too. So I'll probably skip those for now. Although oh man, I'm gonna have to try one of them. That's kind of a small one. Oh, it's trying. I don't know what it's going to
Like
do
I
here.
said, it'd be better if you used WGet.
Yeah, probably. Let's see if this thing decides to load. I don't know if it will or not.
Usually, when you have to do with an MPEG-4 on a browser, it's usually not the greatest.
Yeah, yeah.
That's why I always prefer using WGet and use VLC after it's downloaded.
Yeah, yeah, yeah.
Try playing it. Hit the play button.
Yeah. Thought of that. Yeah, I'm not seeing
like
anything.
I said, you better using WGet.
The other thing I can do is just save it like that. And we can put it wherever it decides to put it. I don't know where it's going to put it. Is it thinking? I don't know what exactly it's doing here. It's taking its time. There we go. Let's see. Let's put it here. We'll go live. We'll put it in 190412. Oh, here we go. Save it.
You don't want that. Now it should.
Yeah, and then I'll play it inside of VLC.
Yeah, that's how you do it.
That's how you do it. Take a couple of seconds to upload it here. There we go.
Here we go.
Hold on to your hats. Here we go.
Oh, computer, don't fail me now.
Ooh. Wow. Isn't that great? And how this stuff, it shoots out and then it falls back. See that? Isn't that amazing? Oh, a little bit of a flare there.
This was last month's encounter.
Yeah, just a couple of weeks ago, a few weeks ago. See how this stuff, it just shoots out, then it falls back in, and shoots out and falls back in. Pretty amazing. Well, I don't know why it did that. There we go. So pretty amazing. Pretty amazing little spacecraft. It's an 8-inch telescope. That's it. Tiny, tiny little thing. But wow, that's great.
Yeah.
I don't know if we can zoom in on that or not. Let's try. It doesn't look like it. No. Probably zoom in over here though. Is it? There we go. Interactive zoom. Let's see if we can move it around a little bit. There we go.
Yeah, looks like a demon when you zoomed it in.
Do not let the colors. So these colors, these are false colors. These are not true true colors. We're looking at the sun in the ultraviolet. So these are not, you know, the actual colors on the sun. This is data that has been colored a certain, you know, reds,
And what
oranges.
version is your BLC, by the way? Because I got the 3.0.6.
Oh, I don't know.
Oh, there you go.
3.0. I think I have to update it.
I got the 3.0.6.
Oh, all right. Yeah, I love VLC. It's one of those great things I like to have around all the time. So wow, look at how that's just swirling around in there. Wow.
It's great doing DVDs without need of any additional software.
Yes. Yes. VLC is a nice universal tool that plays all kinds of video and audio. Yep. Sweet.
Now, it's kind of a bit crazy but true, but newer computers can handle Impact 4 much more easier than a desktop that's meant for XP.
I'm not surprised at that. We'll let this one load. We'll watch it, and then I think I'm going to get out of here for today. So this is just a different wavelength. Actually, no. It's the same wavelength. It's just it might be different. I'm not quite sure what the difference is here. I think it might just be different colorizing things. So let's take a look anyway. See what it has to say. Here we go. Pretty incredible. Oh, I'll zoom in this way, I guess. Effects. I always forget which one it is. There we go. Pretty incredible.
Yeah, bears
wow,
great.
Look at that. Isn't that fantastic? Amazing. Oh. There we go.
It's about to reset too.
Yeah. Very cool. Oh, I don't know what happened there.
You full framed.
I must have. Yeah. So lots of things going on down there, but you know, this is pretty much as detailed as we can get, and you know, every single pixel on here is absolutely huge. Right, this area, you know, that we're looking at here is probably at least the size of the Earth. It's probably larger than the size of the Earth itself. Just this little tiny area here. So just absolutely amazing how enormous and incredibly dynamic the sun is. Just incredible. Swirling and twisting and popping up and falling back, and look at that. Wow. Incredible. Absolutely incredible. I'm sure glad it's doing what it's doing. I hope it continues to do exactly what it's doing for a long time, but I don't think that's going to happen. You know, the sun is is always changing. So yeah,
But
enjoy
it's
it
yet
while it
to run
lasts.
out of gas.
Yeah, hasn't run out
And
of gas yet.
it,
All right, well, awesome. I think I'm going to look at the chat here again really, really quick. And all right, well, awesome. All right, everybody. Well, you know, I think I'm going to get out of here for now. I am definitely out of coffee. Haven't This is still full though, so I've been talking way too much. So I'm going to get out of here for now. So thanks everybody again for coming in. Come on in anytime you want. Right? I am here every single day, 2 hours UTC. Now sometimes I um, I'm not able to make it, but most of the time, you know, I am. I don't have that much of a life, so it's extremely easy, you know, for me to be here almost every day. And you know, talking astronomy, we're talking space, we're talking science things, nerdy things, almost whatever, almost whatever. So, all right, everybody. Well, have a great evening and a great day. Make sure to subscribe. Smash the thumbs up if you so desire. Spread the word about this live stream. You know, my goal is to share and spread my passion for science and astronomy and space and all of those kinds of things. So the more we can reach, the better it'll be. And yeah, you know, this channel is growing slowly, and I think that's absolutely great. Got a great crowd here, and yeah, I think it's absolutely fantastic. So come on in anytime. You can come in each and every day if you want, or every week, every month, whatever you desire. So okay, everybody, peace, cheers, and all that. Live long and prosper.
live long and prosper.
And I will see you in a little less than 23 hours, just a little less than one spin. So hold on to your hats, because it's a crazy ride, right? Traveling 1,000 miles an hour. That's just insane, right? But we're doing it, and we do it every single day. So just hold on tight. We'll be all right. Okay, everybody, take care. I will see you later. Bye.